All right, exponential transformations is what we're going to be looking at today. Of course, when I talk about transformations, I'm talking about the same transformations that we've discussed back when we were looking at quadratics and square root functions. So all of this stuff on the board over here, I'll keep referring back to it today. All right. Before I do that, though, just real quick, that exponential that we've been looking at is one in the form y equals a times b to the x power. Now, at this point, all of us should know that the a represents what? What is the a?
Starting value.
It's our starting value. We can always find that right next to what number in the table? 0, which is also our y-intercept, okay? And we've discussed that already. What about the b? What does the b represent?
Ratio.
The ratio. It's the ratio or the pattern in our y values. It's what we're multiplying by. What we're going to look at today is instead of looking at the table, we're going to look at the graph and see what kind of transformations occur based on this a and b. All right, so here we go. You are going to need your calculator, so make sure everybody's got your calculator. Notice here there's a specific window they want us to use when working with this. So, to save some time here, I need everybody to do this one because we messed with this calculator last year and we need to adjust it. So everybody go to reset your calculator. Everybody still remember how to reset, right? Second plus 7, 1, 2. Second plus 7, 1, 2. Once you have your calculators reset, what we're going to do first is adjust our window. So everybody go to your window button. And we're going to set up our x minimum to -6, our x maximum to +6. We'll still use that same scale of 1. Our y minimum is -4. Our y maximum is +4. And again, we'll keep the scale at 1. We just want to make sure the graphs that we're getting match up with what we see on the handout. All right, so here's the deal. Now that you have your window adjusted, of course, we're going to be looking at the equation in this form right here. So if you look at the first equation that we're given, y equals 2 to the x power. There is an a and there is a b in this problem. It's just that you can't see the a right now. And what is that a value? What's the number in front of the 2? 1. Matter of fact, they gave it to you right over here. So the equation really is 1 times 2 to the x power. So make sure you fill that in for me on your paper. Same thing for that second equation, y equals 3 to the x power. There is an a and there is a b. The a value is 1, the b value is the 3, which means the equation really is 1 times 3 to the x power. And then, of course, that last one there's the same thing, 8 to the x power. The a is 1, the b is the 8, which means the equation we're really looking at is 1 times 8 to the x power. So even though you don't see the a value, it is there, an invisible 1. All right, so what I want you to do is go ahead and go to your calculator and type in all three of those formulas. In y1, type in the first equation. In y2, type in the second equation. And in y3, type in the third equation. Get all those in for me. By the way, if you look closely at all of these equations, notice they do have one number that happens to be the same in all of them. What is that number? 1. Notice all the a values on these three examples here all have a value of 1. All right, now that you got it in your calculator, look at the graph. The question is, does your graph on your calculator look like what we have on our paper? Yes. Notice that a value is 1 on every single one of the equations. What do you notice about the graph? They all have something in common. What do they all have in common? They all touch the 1. They all have a starting point of 1. They all have that y-intercept of 0, 1, or 1. All right? What else do we notice about these three graphs besides they all share that same y-intercept? Let me ask you this. Are all three graphs exactly the same? No. They're different from each other. Now, the y-intercepts are the same, but they are different from each other. How are they different? Well, you notice that some graphs are steeper than others. Okay? So, now here where it says, how do these graphs compare? A couple of things I want you to write down for me. First thing I want you to write down is they share the same y-intercept. They all have the same y-intercept. And that y-intercept happens to be 0, 1. That's the first thing I need you to write down. They share the same y-intercept. And the reason they all have the same y-intercept is because they all have the same a value. They all have an a value of 1. But you'll notice they all have a different b value. One of them has a 2, the other one has a 3, the other one has an 8. So what is it that that b value is doing to the graph? Well, it tells you right here that b value is our increase. What it does is it makes the graph steeper. What it's doing, and I'm going back to that transformation that we talked when we were looking at quadratics and square roots. It gives us a horizontal compression. We're squeezing it in from the sides. And when you squeeze this graph in from the sides, it's going to make your graph look a little steeper. So that's what the b value is doing. The bigger that number is, the more we're going to compress it. And of course, the more you compress it, the steeper your graph is going to be. All right, so that's set number 1. Now let's take a look at the next set of equations. Here's the next set. So again, let's go to our calculators. And in y1, we're going to type in the first equation, 0.6 to the x power. In y2, we'll type in 0.4 to the x power. And in y3, we'll type in 0.1 to the x power. Now this set of equations, just like the first set of equations, has an a and a b. So if you look at the second equation, 0.4 to the x power, Mason, what is the a value on that equation?
0.6.
No, I'm looking for the a. 1. B is that 0.4. If you look at the last equation, it also has an a value. Samantha, what is the a value on that last equation? I'm looking right here at the last equation. What's the a value? What's the number in front of the 0.1? I'm looking at this equation right here. I want to know what is in front of my 0.1 to the x power. A 1. Our b value is the 0.1. All right. Make sure you get that in your calculator, and let's take a look at the graphs. I want to point out, just like the first set of equations, notice how the a value is all the same number. So what is that going to mean for the graph, Garrett? If all the a values are the same number. There you go. They're all going to have a y-intercept of 1. So when you put this in your calculator, is that the graph you're getting? Yes? All right. So this is the graph we're getting. Notice how all of those have the same y-intercept, which is 1. And that's because our a value is 1. So how do these graphs compare? Well, I just told you one of them, and that is that they all share the same y-intercept. They all have the same y-intercept, which is 1. Just like the first set that we looked at, that b value is causing our graphs to get steeper. Again, what we're doing is we're compressing this graph horizontally. We're squeezing it in from the sides. And when you squeeze it in from the sides, it makes the graph steeper, steeper, and steeper. Now this one is slightly different. If you look closely, it is different from the first set. Can you see what else is different? But I didn't put it on.
It goes to the right.
What do you mean it goes to the right?
Like this, like the first one, it went like this way and it went that way.
Ah, okay. Can you describe that a little bit better? 'Cause I can't put it goes this way and goes this way. Okay. Okay. So I want more specific.
Exponential decay?
What? This one? I don't know. You tell me. When you say exponential decay, what the heck does decay mean? Because I don't think anybody else knows. What? Decrease. That's the word I was looking for. Notice this time the graph decreases. It starts up here and then it goes down. So notice this time the graphs are decreasing. So make sure we include that. All right. So let's put down over here that they decrease. All of these graphs here are decreasing. They're going down. You remember on Tuesday we were looking at exponential growth and exponential decay. This is an example of an exponential decay. Decay because it's going down. decreasing. All right. Why? Anybody know why this one is decreasing? What's different about these equations compared to that first set that we looked at? They're decimals. They're numbers between 0 and 1. That's why we're getting a decrease. And we'll talk more about that in a minute. All right, let's look at the third set. Now, in this third set, they didn't give us the first equation. All they told us is what A is and what B is. Well, if I know what A is and B is, don't I know the equation then? Can't I write the equation? Alexander, what would be the equation? Y equals what? All they told us is that A is 2 and that B is E. So what would be the equation? And there it is, 2e to the x power. That is correct. Matter of fact, we can do the same thing with that third equation down there. They told us A, they told us B. So what would the equation be then? Garrett, what would be the equation? 0.5 times e to the x power. So these are the equations we're working. Now let's time out here for a second. Our B, notice how the B value is the letter E. But didn't we say earlier that the B value represented our ratio? It was what we were multiplying by. So shouldn't it be a number? Yeah. So the question is, what is E? Is E a letter, a verb, or is it a number? Well, let me ask you this. Anybody know what that thing is?
Pi.
And what does that mean? It's a number. What number is it?
Really long way.
It's a really long one. 3.14 something, 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 something. Okay? So, that symbol right there represents a particular number. Well, it's the same thing with this E over here. E is a number that we use, especially in pre-calc. And I'll get to that a little bit later. But what I want you to realize right now is that E is a number. In this particular case, that E, first of all, do we have an E button on our calculator? Look on your calculator.
Yeah.
See if you find the E button. All right.
Double E.
See it? Where is it?
Above saying.
Above what? Well, actually, it's in two different places depending on where you're looking at. Look, right above the division sign. See the division? Y'all see it?
Yeah.
Get a clear screen and hit that E button, and then just hit enter. And what is E? 2.7182 something, something, something. Okay, so that E represents an actual number. So because you see that letter E doesn't mean that it's another variable. It is an actual number. So we're not going to get too much into detail about that E. You'll talk more about it when you get into pre-calc. Okay? I just want you to understand that it is a number. All right, so now that we know that, let's take a look at the three graphs of these three equations. Okay, so go to y equals 20. And in y1, I want you to type in the equation 2e to the x power. In y2, I want you to type in 3e to the x power. And then in y3, type in 0.5 e to the x power. And then get it correct. And if we type it in correctly, our graph should look something like this right here. Now my first question is, are all the y-intercepts the same number? No. Okay, so again, do they all have the same y-intercept? No. How come all the y-intercepts are different this time?
Because all the different places.
Ah, look at the A's. The first one has a 2, the next one has a 3, the next one has a 0.5. So the reason we have different y-intercepts is because we have different A values. So that's the first thing I want you to notice. The first two that we looked at, they all had the same y-intercept, and that's because all the A values were the same. Well, now they're all different, which is why we're getting different y-intercepts. Okay, so over here, how do the graphs compare? Well, the first thing you should know is that they have different y-intercepts. They all have different y-intercepts. But besides that, the fact that they have different y-intercepts, that A value, that 2, that 3, and that 0.5, is also doing something else with the graph, and that is that it's vertically stretching or vertically compressing the graph. Okay? Looking right here. We're stretching or compressing the graph vertically. Then we talked about stretching and vertically compressing graphs when we were talking about quadratics and square roots. We talked about that. Isn't that one of our transformations that we have over here on the board? This one right here. So notice in this particular case, two of these graphs are being stretched vertically. One of them is being compressed vertically. Question is, can you tell the two for the three apart? Which two equations are the ones that are being stretched vertically, Samantha? Look over here. Get the red. We talked about these transformations. Stretch it vertically. Look here. To compress it vertically. Look here. So again, Samantha, I'm asking you, which two equations are being stretched vertically? Okay, that's one of them. Y equals 2e to the x power, and that's right, 3e to the x power. How did you know those were the two that were being stretched vertically? It wasn't a decimal, all right? And that last one, of course, is the one that's being compressed vertically because it's a, well, let's be careful, not just because it's a decimal, but because it's a number that's between 0 and 1. Okay? So we'll be a little more specific. All right, so that's set number 3. Now let's go to set number 4. On set number 4, again, notice the first equation, they did not give it to me, but it's all right. I know what A is, I know what B is, so I should be able to come up with the equation. What is that equation? Virginia, what is the equation?
6 is 4 with the parentheses, 0.5.
All right, to the x power, very good. And then, of course, that last one there, y3, would be the same thing. -2, that's our A value, times 0.5 to the x power. Now, notice on this one, the A values are different, the B values are the same. So, A values are different. A values are different. What is that telling us when the A values are different? If I look at the graphs, what am I going to notice? Different y-intercepts. Very good. Different y-intercepts. So go ahead and graph that for me. Put that in your calculator and sketch me a graph of what you see in your calculator. Again, we should be seeing different y-intercepts, and that's because all the A values are different. We got a 4, a 2, and a -2. Sketch me a graph. And let's see if you get the same graph that I got. Same thing you're getting? All right, so go ahead and sketch that for me. By the way, what do you notice about one of those graphs in particular? It's upside down. Why is one of them upside down? Anybody know? What negative? The -2. That A value right there, that negative sign, is flipping it upside down. What do you call that when you flip that thing upside down? Reflection over the x-axis. Okay, so that negative sign is giving us the reflection over the x-axis. So let's come over here and compare. First thing that we notice is that the y-intercepts are different. The y-intercepts are different, and that's because of the A value. Now we also mentioned that A value is what's causing our vertical stretching and our vertical compressing. So let's make sure that we add that in there. The bigger the number is, the more we stretch it out. And we also want to include in there the fact that that negative sign is giving us a reflection over the x-axis. Make sure we include that. Didn't we see negative signs giving us a reflection in parabolas? Didn't we see negative signs giving us a reflection in our square roots? Sure. So all that stuff that we've already talked about, here it comes again. All right, so that takes care of the fourth set. We got two more sets that we need to look at, and that's going to be on the second page there. Now, the next two sets are going to be slightly different from what we've seen so far. And that's because the equation we're going to be looking at now is this right here. Y equals A times B to the x power plus K. So notice we threw a little monkey wrench into this, and that's the plus K. So now we're going to see what is it the plus K is going to do to our graph. Anybody want to take a guess before we actually see it? Anybody want to come up with it? Move it up or down? Anybody want to go something different? Left or right? All right, so let's see. Which one is it going to do? Is it going to move it up or down, left or right, or something completely different? Let's find out. All right, so these are the three equations that we're working with. Notice there's three things here. There's an A, there's a B, and there's a K. On the first equation, A is a 2, B is a 3, and K is a 0. So there is no K, there is no plus number on it. What about the second equation? What's the A for the second equation? 2. The B for the second equation is 3, and the K is a 1. I'm looking at that plus 1. The last equation, what's the A value for the last equation? 2. The B value is 3, and our K is a -2. All right, we're going to put this in the calculator, but before we do that, what do you notice about all the A values? They're the same. And what did we say earlier about the A values if they were the same? They were going to have the same y-intercept, right? Remember that? If the A values are the same, we're supposed to get the same y-intercepts. Is that what's going to happen this time? Well, let's find out. Go to your calculators. Let's go to y equals, and in y1 we'll type in 2 times 3 to the x power. In y2 we'll type in 2 times 3 to the x power plus 1. Now just a little warning here, guys, make sure when you're typing in that plus 1, make sure that it's not part of your exponent. So you may have to hit your right arrow key over once so that the plus 1 is not part of your exponent. Then we'll type in 2 times 3 to the x power minus 2. Again, be careful that the minus 2 is not part of your exponent. And then let's take a look at the graph. And this is the graph that I'm getting. That's the same thing you're getting? Yes. Now remember, on the first couple of examples, we said if the A value was the same, it represented the y-intercept. But is that the case here? Do they all have a y-intercept of 2? No. And why don't they have a y-intercept of 2 this time? Because of the K. So the question is, what is the K doing to the graph? And we took a couple of guesses here. So what's the correct answer? What's happening here is that the K value is translating our graph vertically, meaning it's either moving it up or it's moving it down. So that second equation, the plus 1 actually moved the graph up 1 unit, which is this graph right here. Y3, that minus 2, is moving the graph down 2 units. That's this one right here. So the K value is moving your graph either up or down. That's what K does to the graph. Move it up or down. So let's take a look at the last set. Of course, the first equation is already given to us. They told us what A, B, and K are. We look at the equation for the second equation. What is our A value? There is one there. You just can't see it. 1. B is our 0.4, and K is a 1. Now be careful on that last one. What is the A value for Y3? Good, -1. Our B value is the 0.4, and our K value is 1. So here's the equation. So if we were to graph these things, here's what we're going to end up with. These are the three graphs. So then again, the question is, how do these graphs compare? Well, again, that A value is giving us stretching. That's what the A value is doing, it's stretching it vertically. What does that negative one do to the graph? What does the negative sign do to the graph? Flips it over the x-axis, giving us a reflection. That negative sign is giving us a reflection over the x-axis. And all of these graphs have y equals 1 as their axis. So we've looked at 6 different sets so that we can identify what A does to our graphs, what B does to the graph, and what K does to the graph. So now that we know what each of these does, let's go ahead and summarize it in the middle of your page. Okay, so the equation is A times B to the x power plus K. So let's start with the A. What is the A doing to the graph? Well, again, it depends on what the number is. If A is a number that's larger than 1, what's going to happen is we're going to vertically stretch the graph. We're going to vertically stretch the graph. That's this transformation in red over here. If the number is between 0 and 1, like Samantha said earlier, a decimal, then what's going to happen, Samantha? Not a vertical stretch, but a compress what? What's the word I'm looking for? Vertical. Vertical compression. We're squeezing it from top to bottom. But what if it's a number that's less than 0? What if it's a negative number? What is the negative sign doing to the graph? What is the negative sign doing to the graph? Flips it. What do we call that flip? Let them call it flip. Reflection over the x-axis. If it's a negative number, we're going to get a reflection over the x-axis. That's what A does to the graph, guys. Still up here on the board. That's the one in red. Okay. If we multiply the function by a number greater than 1, we're going to stretch it vertically. If it's between 0 and 1, we're going to compress it vertically. And if it's less than 0 or a negative number, we reflect it over the x-axis. Now let's talk about B. If B is a number that's greater than 1, then we're going to have an increase. We're going to have an exponential growth. But if the number is between 0 and 1, then what's going to happen is we're going to get a decrease. It's going to be an exponential decay. So that B value is going to tell us whether the graph goes up, increases, or if the graph goes down, decreases. And then the last thing, the K, we already said what K does, right? What is K going to do to the graph? Move it up or down. So if the number is greater than 0, what is it going to do? Move it up or down? Up. If it's less than 0, then it's going to move it down. And then if y is equal to k, that's going to represent our horizontal axis. Horizontal axis. All right, so we've just summarized what A does, what B does, and what K does to our exponential function. All right, I'm going to go ahead and skip this part at the bottom here. I want to make sure that we get to the last page. And on this last page, I'm just going to kind of summarize the main idea of what they're trying to get to here, because we're running out of time. So if we look at the first part, first half of the page here, it says, what happens if B is a series? So we're not going to go through the whole thing. What I want you to do is in y equals, I want you to type in this equation for me only. And y1, type in 4 times 0 to the x power plus 2. What happens when we use a 0 for our B? Graph it, see what you get.
Straight line.
What's that?
A straight line.
A straight line. So I thought we were doing exponentials. I thought we were supposed to get either a curve that goes up or a curve that goes down. Did anybody get a curve that goes up or down? So then you're all getting a line that looks like this. All right, so the question is, Why? Why are we getting a line that looks like that rather than an exponential growth or an exponential decay?
Zero.
The
Zero
ratio
in
is
it.
zero.
Because the what?
Ratio.
The ratio is 0. Our pattern is
Always equals zero.
it's always 0. We're always multiplying by a 0. Okay? So basically what's happening here is that this part of the equation is always giving us a 0. And 0 plus 2 is always going to be a 2. So notice how the y value is always a 2, 2, 2, 2, 2, 2, 2, 2. No matter what x value we use, our y value is always a 2, 2, 2, 2, 2. Okay? So over here, how are the functions alike? How are they different? The main thing I want you to write down here is that the last equation, or y4, is linear. y4 is linear. And why is that one linear? Because we use 0 for b. No, I don't know if you noticed this, but that line that we drew, notice it doesn't go in both directions. It starts on the y-axis and goes to the right. Notice we did not go to the left, so we're not including any negative x values. So, because of that, because we're not going to use negative exponents, our domain ends up being x is greater than 0. X greater than 0. We can't use 0 as an exponent, and we can't use a negative number for an exponent. At least not for 0. Not when we're using 0 for b. So in summary here, what they're trying to get you to see in this particular section here, guys, is when it comes to our exponential, our b value, we can never use a 0. Never use a 0 for b. And why is it that we don't want to use a 0 for b? Because then it's going to give you a straight line. That's exactly why. We're going to end up with a linear rather than a exponential. The bottom line here is don't use 0 for a b. Don't use 0 for a b. All right, last thing here, the last half of the page. I'm not going to do the whole thing. We're just going to summarize it real quick. What happens if b is a negative number? Go to your calculator and let's see what happens when b is a negative number. Go to y equals and type in for me 3 times negative 4 to the x power. I think we mentioned this already the other day, but just in case. Go to your table first. And in your table, you see the order pair 0, 3, 1, negative 12, and then what?
248.
248, and 3, negative 192. Now, make sure, if you want to see the graph, make sure you're using the correct window there. So change your window so that it's negative 4.7 and positive 4.7. Use the scale of 1. The y minimum is negative 500. The y maximum is positive 500. The scale we're using is 100. Then hit graph, and you should be able to see your graph. Now notice this graph is going to look different from the other ones that we've seen. And what do you notice? You see a bunch of little dots. Why? Why do we see dots instead of that exponential growth or decay? What do you notice about the table, guys? It goes from a positive number to a negative number, then to a positive number, then to a negative number, and back and forth and back and forth and back and forth. So, we talked about this the other day. In order to be an exponential, these y values have got to continuously get smaller, 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 or they got to continuously get bigger, 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 bigger. And that's not what's happening here. Okay, so that's why you see a bunch of dots, some up, some down, some up, some down. And that's because of that negative b value. So, what do they want us to see out of this particular section? That b cannot be a negative number. Okay? B cannot be a negative number. And that's C right here. Why don't we want b to be a negative number? Because then we end up jumping back and forth between negative and positive values. So just make sure you fill out C for me. So the bottom line for that last page is we cannot have two things for our b. What are the two things that we can't have for a b? A negative number
The zero.
and a zero. Don't use a zero and don't use a negative number for b. That's what we want to get out of the last page. All right, so that takes us through exponential transformations.